6 billion kilometers from the Sun, two frozen worlds share a single orbit, locked in a pattern that breaks nearly everything we think we know about how moons are made. By the ordinary rules of planetary collision, an encounter like theirs should have ended one of two ways. Either the smaller body is shattered into a ring of debris, or it is swallowed whole, absorbed into the larger world until nothing distinguishes them apart. There is no third outcome, not according to physics. And yet here they are, two separate worlds, still intact, still spinning together around a point of empty space that belongs to neither of them. Not a planet with a moon in its grip, something stranger, a pair holding each other at arm's length, forever. This is not the story of when a moon was found. Telescopes had already caught glimpses of something strange near the edge of the solar system decades before anyone understood what they were looking at. This is the story of how that moon should never have existed at all, and the narrow, almost accidental sequence of events that let it survive being born. This is the story of Charon, and the collision it was never supposed to walk away from. To understand why Charon shouldn't exist, you first have to understand what usually happens when two worlds this size run into each other. Across the solar system, most large moons form through violence. A young planet is struck by another body, often at tremendous speed, and the impact either destroys the smaller object outright or blasts enough material into orbit to eventually reassemble into a single moon. A process scientists sometimes model using our own moon as the reference case, where a Mars-sized body is thought to have slammed into early Earth, throwing molten debris into orbit that later cooled into the satellite we see tonight. That model works because the bodies involved are largely molten during the encounter. Rock and metal can splash, melt, and reform. But out at the edge of the solar system, roughly 40 times farther from the Sun than Earth, the physics are entirely different. Bodies like Pluto and its would-be companion aren't balls of molten rock. They are cold, rigid worlds built from a mixture of stone and enormous quantities of water ice, frozen solid for billions of years. Ice under those conditions doesn't behave like molten rock. It shatters. A high-speed impact between two icy, rigid bodies isn't likely to produce a stable pair. It's likely to produce wreckage. One winner, one casualty, and a debris field scattered across a very cold and very empty stretch of space. So when astronomers eventually turned their full attention to the pair we now call Pluto and Charon, the puzzle wasn't simply, when did this moon form? It was something closer to a contradiction. Two worlds, similar in composition, similar in age, sitting almost side by side in near equal partnership. A configuration that the standard collision model says should be essentially impossible to produce intact. Something about their encounter had to have been different, slower, gentler, survivable. And figuring out what that difference was would end up rewriting our understanding of how small worlds are born at the outer edge of the solar system. This isn't a minor academic puzzle either. Out beyond Neptune, in the vast dim region known as the Kuiper Belt, collisions like this one happen far more often than they do closer to the Sun. Trillions of icy bodies drift through that region, occasionally crossing paths, occasionally merging, occasionally shattering each other apart. If we can figure out exactly what conditions allow two of these worlds to collide and both survive, we're not just solving the mystery of one unusual moon. We're building a working model for how an entire population of small, icy worlds across the outer solar system may have paired off, merged, or torn each other to pieces over the last 4.5 billion years. Charon isn't an isolated oddity. It may be the clearest surviving example of a process that shaped far more of the outer solar system than we currently give it credit for. If the standard collision model were correct, we would expect one of two outcomes: a single dominant world with debris scattered around it, or a small moon locked deep inside its parent's gravitational grip, orbiting a center of mass buried far beneath the larger body's surface. That's how nearly every planet-moon pairing in the solar system works. It's how Earth and its moon work. Our moon carries only a small fraction of Earth's mass, about 1 part in 81, and the shared center of gravity between the two worlds sits comfortably inside Earth itself, nearly 1,700 kilometers below the surface. Charon breaks that pattern entirely. Charon carries roughly 12% of Pluto's total mass. To put that in context, that's an order of magnitude more significant, relative to its parent, than nearly any other major moon in the solar system holds. And because the two bodies are so close in mass, the point they both orbit, the barycenter, the true center of gravity for the system, doesn't sit inside Pluto at all. It floats in open space, roughly 960 kilometers above Pluto's surface, in the emptiness between the two worlds. Pluto and Charon don't orbit each other in the traditional sense. They orbit a shared point that belongs to neither of them, locked together like two dancers turning around a spot on the floor between their joined hands. The strangeness compounds from there. Our own moon is tidally locked to Earth. It always shows us the same face, though an observer standing on the moon would still watch Earth rotate through a full day-night cycle overhead. Pluto and Charon take that phenomenon to its logical extreme. Both bodies are locked to each other simultaneously. Charon always shows Pluto the same face. Pluto always shows Charon the same face in return. If you stood on the Charon-facing hemisphere of Pluto, the moon would hang motionless in your sky forever, never rising, never setting, simply present. Stand on the opposite hemisphere, and you would never know Charon existed at all. Two worlds, staring at each other across 19,640 kilometers of space, forever, without ever looking away. Compare that to nearly any other major moon in the solar system, and the pattern breaks down completely. Jupiter's largest moons, massive as they are, still amount to a tiny fraction of Jupiter's own mass. Even Neptune's largest moon, Triton, itself an oddity, likely a captured world, rather than one born alongside its planet, orbits a planet roughly thousands of times more massive than itself. Charon, by contrast, sits at essentially its own weight class relative to Pluto. There is no comparable pairing anywhere else among the 8 major planets and their moons. It stands alone as the one case where a moon carries so much of its parent's mass that calling it a simple satellite starts to feel like the wrong word entirely. None of this is what a violent, standard model collision should produce. A shattering impact doesn't leave behind a gently balanced, mutually locked pair of survivors. It leaves behind rubble. So the real question wasn't just how big Charon was. It was how a collision violent enough to produce a moon this large could possibly have ended without destroying one or both worlds completely. For years, the leading explanation for Charon's formation was simply a smaller scale version of the same violent impact model used to explain Earth's moon, a high-speed strike, a shattering debris coalescing into a companion. It was a reasonable starting assumption, but as scientists built more sophisticated simulations and factored in the true rigidity of icy bodies at these temperatures, the model kept breaking down. High-speed collisions between rigid ice worlds didn't produce 2 intact survivors in the simulations. They produced destruction. A newer, more careful model has since taken its place, one that resolves the contradiction by proposing something almost the opposite of a violent strike. Instead of a high-speed impact, this model describes a slow, glancing graze, 2 proto-worlds drifting into each other gently enough that, rather than shattering, they briefly stuck together. For a matter of hours, the 2 bodies spun through space, fused into a single, misshapen mass, like 2 lumps of wet clay pressed briefly together. Then, as their combined rotation and gravity pulled against each other, they separated again, not completely, but just enough to settle into the locked mutual orbit we observe today. This is the narrow window that let both worlds survive. Slightly faster, and the encounter shatters both bodies into a debris field with no clean survivor. Slightly slower, and the 2 proto-worlds never separate at all. One absorbs the other, and there is no Charon, only a slightly larger Pluto. The system we observe today exists because the encounter landed almost precisely in between those 2 outcomes. Not an inevitability, a survival, threaded through an extremely thin margin of physical possibility. This gentler model also explains something the violent impact theory struggled with. The 2 worlds aren't identical in composition. Pluto is denser and more rock-rich, made up of roughly 70% stone by mass. Charon is lighter, closer to 55% rock, with proportionally more ice. If the two bodies had been thoroughly melted and mixed together during a shattering impact, we would expect their compositions to be nearly identical. Instead, they look like two worlds that largely kept their own internal structure intact through the encounter. Exactly what a gentle, low-speed, kiss and separate event would predict, and exactly what a violent, shattering collision would not. But surviving the encounter came at a cost. The heat generated by that brief, violent embrace, and by the tidal stretching that followed as the two bodies pulled apart from each other, didn't simply vanish. It went somewhere, and where it went would determine the entire future geological history of the smaller world. The energy injected into Charon during its formation had to go somewhere, and the most likely destination was straight down into the moon's icy interior. That heat, combined with the slow decay of radioactive elements buried in Charon's rocky core, was enough to melt a portion of the water ice deep beneath the surface, creating, for a period in Charon's early history, a genuine subsurface ocean sealed beneath a solid crust of frozen water. Oceans on small, icy worlds don't last forever. Over time, as a body this far from the sun radiates its internal heat away into space, that hidden ocean began to freeze from the outside in. And this is where an ordinary property of water becomes the engine of a global catastrophe. Almost every substance in nature contracts as it freezes, taking up less space in solid form than in liquid form. Water does the opposite. It expands. As Charon's buried ocean slowly turned to ice, it grew, pressing outward against the rigid shell of frozen crust, sealing it in from above. Crust can only stretch so far before it breaks. Eventually, the pressure from below exceeded what Charon's surface could withstand, and the moon's crust tore open along its weakest points, ripping apart in a belt of canyons that wraps around a significant portion of the world's circumference. These aren't valleys carved slowly by flowing water or wind, the way canyons form on Earth. They are pull-apart fractures, direct physical evidence that the entire outer shell of a small moon was stretched past its breaking point by an ocean freezing solid beneath it. In places, these canyon systems run for well over 1,000 kilometers and plunge several kilometers deep, rivaling, and in places dramatically exceeding the scale of the largest canyon systems found anywhere on Earth. Because Charon has no thick atmosphere and effectively no ongoing geological activity today to erode or bury these scars, they remain remarkably well preserved. A frozen, permanent record of the moment. An entire world's internal ocean sealed itself away and tore the surface open on its way out. Scattered across the smoother, resurfaced half of Charon, mission images revealed something else that doesn't fit neatly into either category. Isolated mountains, standing alone in the middle of otherwise flat plains, each one sitting inside its own shallow depression, almost like a moat carved around its base. The leading explanation is almost as strange as the feature itself. These may be enormous fragments of the older fractured crust that broke free during the resurfacing event, carried along like icebergs riding on top of the slow-moving icy flows, before finally coming to rest and freezing in place as the surrounding plains solidified around them. If that explanation holds, then these mountains aren't native to the ground they now sit on at all. They are transplants, foreign chunks of Charon's own ancient surface, stranded in terrain that didn't exist when they were first formed. And the freezing ocean left more than just canyons behind. As pressure built beneath the cracking crust, some of that trapped liquid, likely mixed with compounds that lowered its freezing point, acting as a kind of natural antifreeze, was forced upward through the newly opened fractures and out onto the surface. Not molten rock, but icy slush, flooding across a broad stretch of the moon's landscape and freezing into vast, smooth plains that stand in stark contrast to the older, heavily cratered terrain nearby. One half of Charon still bears the raw, fractured scars of its ancient breakup. The other half was resurfaced entirely, paved over by the very ocean that caused the damage in the first place. There is one more feature on Charon's surface that doesn't come from anything happening inside the moon at all, and it may be the clearest evidence yet of just how tightly bound these two worlds remain, even now, long after their violent beginning. At Charon's northern pole sits a wide, dark, reddish stain, unlike anything else on the Moon's surface. The color comes from a class of compounds called tholins, a tar-like reddish material that forms when simple organic molecules, particularly methane, are struck by ultraviolet light and cosmic radiation over long periods of time. Tholins show up across much of the outer solar system, but their concentration at this single spot on Charon, and nowhere else on the Moon, points to something specific happening at that pole, and possibly to something arriving from outside Charon entirely. The leading explanation ties this red stain directly back to Pluto. Pluto's thin atmosphere is slowly leaking away into space, carrying trace amounts of methane with it. As Charon completes its orbit, a portion of that escaping gas drifts close enough to be captured by the Moon's weak gravity. Charon's polar winters last for more than a century at a time, plunging temperatures at the pole below -240 degrees Celsius, cold enough that any captured methane freezes directly onto the surface, rather than simply passing through. When sunlight finally returns to that pole, after generations of darkness, ultraviolet radiation bakes the accumulated ice into the reddish tholins we see today. In effect, Pluto has been slowly painting its companion's pole for millions of years, one century-long winter at a time. A competing explanation suggests the source might be closer to home, that some of the methane could have come from Charon's own interior, released during the same cryovolcanic eruptions that resurfaced its southern plains. Under this version, gas trapped in the ancient subsurface ocean escaped to the surface during the Moon's period of geological activity, briefly forming a thin temporary atmosphere of its own before migrating to the coldest point on the Moon and freezing out in exactly the same way. Both explanations remain genuinely debated, and it's entirely possible the truth involves some combination of the two. Material inherited from Pluto layered on top of material generated by Charon's own violent past. Either way, the stain at Charon's pole is a kind of signature, proof that whatever happened between these two worlds during their formation didn't simply end once the dust settled. The connection is still active, still visible, written across the top of the smaller world in a color neither body could have produced entirely on its own. Every rule of collision physics says a world like Charon shouldn't be here. A body its size meeting a body Pluto's size at anything close to the speeds typical of the outer solar system should end in one winner and a field of wreckage, not two intact worlds locked in a permanent balanced embrace around a point of empty space. But the numbers don't lie. 12% of Pluto's mass still standing, a barycenter floating in the dark between them, two faces locked toward each other that will never look away, canyons torn open by an ocean that shouldn't have frozen the way it did, a red stain at the pole that may be nothing less than one world's atmosphere, slowly settling onto its neighbor's skin, one century-long winter at a time. Somewhere in the earliest days of the solar system, two icy worlds drifted toward each other on a trajectory that should have destroyed one of them. Instead, for a handful of hours, they touched, held on, and let go, just gently enough, just slowly enough, to walk away from an encounter that, by every ordinary rule of physics, neither of them should have survived. The rules of collision say only one world should have made it out intact. Charon is what happens when the rules almost don't hold.